Dear students, under the lecture series on complex analysis, here we are going to learn problems under Cauchy integral formula. In our previous video lecture, we derived the Cauchy integral formula. Now here we are going to learn the problems under Cauchy integrals formula. So now here, as per the Cauchy integral formula, we know that integral over c f of z by z minus z naught dz is equal to 2 pi I multiplied with f of z naught. So this is the Cauchy integral formula, and this formula is applicable only when f of z is analytic inside and on C. Also, Z naught lies in the interior of C. So once these two conditions are satisfied, then we can apply the Cauchy integral formula. So now using this, we are going to solve problems. Also, we should know that if the Z naught lies in the exterior of C, that is outside C, then the integral becomes 0 because f of z by z minus z naught will be analytic at the point z naught, and hence by Cauchy's theorem the integral will turn out to be 0. So always remember, when it lies inside we have this formula, and when it lies in the exterior of C, that is outside, that is z naught lies outside C, then it will be equal to 0. Also, there are higher derivative formulas using this. That is, whenever you have z minus z naught the whole square, then the formula turns out to be 2 pi I f dash of z naught. So instead of f of z naught, we will be having the first derivative of the function f. So f dash of z naught divided by 1 factorial. In a similar way, if we have the power to be 3, so z minus z naught the whole power 3, then the solution turns out to be 2 pi I multiplied with f double dash of z naught, the second derivative, divided by 2 factorial. And in general, if the power is n plus 1, then it will be 2 pi I multiplied with f n of z naught, which means nth derivative, divided by n factorial. So this is a generalized formula. So these formulas also will be applicable in solving problems under Cauchy integral formula. So first we shall solve problems under by using this formula. So now here we have the first problem under Cauchy integral formula. The question is to evaluate using Cauchy's integral formula 1 by 2 pi I integral over c z square plus 5 by z minus 3 dz, where c is the circle, modulus of z is equal to 4. This circle means the center is at the origin, because we know that the equation of the circle is modulus of z minus a is equal to r, where a is the center and r is the radius. Now here, since there is no a, that is it is 0, we have only z, which means a is 0, so that implies that the center is at the origin and the radius is 4. So as I told you previously, in order to apply Cauchy's integral formula to this integral, we should first check whether f of z is analytic. So we have to check whether f of z is analytic inside and on C. So that is the first condition. Secondly, we have to check whether the point z naught lies inside, that is interior of C. So if these two conditions are satisfied, then we can very well apply the Cauchy's integral formula. Now what is f of z given here in the question? So when we compare with the Cauchy's integral formula, we see that, now if you see, integral over c f of z by z minus z naught dz. So at the place of z minus z naught we have z minus 3, and at the place of f of z we have z square plus 5. So on comparing, we get f of z to be equal to z square plus 5. Now we observe that this is a polynomial, so which is a polynomial, and we know that a polynomial is analytic everywhere. So this implies that f of z is analytic inside and on C. So the first condition is satisfied. Now we shall check about z naught. So if you see here, what is z minus z naught? It is z minus 3. So z minus z naught is equal to z minus 3. So from this, while comparing on both the sides, we get z naught to be equal to 3. Now we have to check whether this lies inside the circle, given circle, inside or outside this given circle. Now what is the circle given? It is modulus of z is equal to 4, which means that the circle has the center at the origin 0 comma 0 and the radius is given by 4. So this is r. So this is the radius. Now if you see, we have z naught to be equal to 3 here. So what is modulus of z naught? It will be equal to modulus of 3, which is 3 only. And this 3 is lesser than 4. And since it is lesser than 4, and it will lie within the circle because the radius is 4 and this modulus of z naught is 3, which is lesser than 4. So it lies to the interior of the circle C. So therefore we can conclude that z naught lies to the interior of C. Interior of C. So the second condition is also satisfied. So first was f of z is analytic inside and on C, and then z naught lies to the interior of C. So therefore the Cauchy integral formula can be applied now. So as per the Cauchy integral formula, we have 1 by 2 pi I integral over C f of z, which is z square plus 5, divided by z minus z naught, which is z minus 3, and then dz is equal to f of z naught. So what is f of z naught? So this is the formula if you see. So that's equal to this 2 pi I is over here, 1 by 2 pi I is equal to f of z naught. So what is f of z naught? It will be f of z naught is 3. So this one. So f of 3. Now the function f of z is over here. So at the place of z we have to replace it by 3. So f of 3 will be what? So that is equal to, on substituting z as 3 over here, it will be 3 square plus 5, which is equal to 9 plus 5, and therefore this integral has been evaluated to be equal to 14. So this is the answer. So I hope you would have understood how to find, like evaluate an integral by using the Cauchy's integral formula. So kindly follow the upcoming video lectures for more problems under this topic. Thank you.